CNBT 1311, we are back. This is video chapter 9, video 2. All right, this is a straight run stair. This is a straight run, okay? In other words, you've got unlimited access over here. It goes up to a landing, which is unlimited access, and that's a straight run. All right, building codes are going to limit that to 12 feet. 12 feet. If you're going to have to go 24 feet, then guess what? You got to have a landing up here, and you got to have another set of stairs going up. The rest of your deal is it's broken up 12-foot max. Okay. Does that make sense? Well, if it doesn't, it will. All right. So this is a straight run stair. Let's get rid of that. All right, straight run stair. All right. If it's more than 12 feet from where you started, you go up a height of 12, then you got to have a landing, and then you got to go up and finish it, and then this would be a termination landing up here. It could just be a giant hallway or floor, but anyway, it would land up here. All right. The building code determines how big these landings need to be and stuff like that. A stairwell may be approached or departed either actually or perpendicular to the stair run. In other words, it can go straight up like that, or you can come to the side and turn and go up the stairs. And the same way with the landing up here. If this is one big giant open area, then you're going to exit actually, or you can turn in perpendicular, right? And that's all it's saying. Quarter turn stair. This is what I have in my house. I have a straight run. Here's the upstairs catwalk and the vaulted ceiling, and I've got a landing here, and then I've got just exactly like this, 2 treads. They're not 3, they're 2, and it's a quarter turn. It is a pain getting a mattress and bookcases in that turn. And gun safes and such as that. So anyhow, so that's a quarter turn. Quarter turn stair. You've got a straight run stair, and a quarter turn or L-shaped stair makes a right angle turn in the path of travel. The 2 flights connected by an intervening landing may be equal or unequal depending on the desired proportion of the stairway opening. Now, this is a good point to make. The riser height and tread depth on mine from the ground floor, this is the ground floor, is different than these. These are all the same, going up to the catwalk landing that feeds the 2 bedrooms and the bathroom upstairs. But this shows 3. I had 2. I have 2. So Bubba built my house, and these treads and risers are different. But it's okay, because once you negotiate this and you're getting on the landing, then you've got this flat piece of real estate up here. You turn, and then you start an even riser and tread pattern all the way up. We talked about before about changing the riser and tread pattern up through here. That's a disaster waiting to happen. You do that, you're probably going to get red tagged when the building inspector sees it. And you really don't want to get red tagged. So that means you got to tear all this out. Half turn stair is just that. Half turn stair turns 180 degrees or through 2 right angles to an intervening landing. A half turn return stair is more compact than a single straight run stair. The 2 flights connected by the landing may be equal or unequal depending upon the desired proportion of the stair opening. So this can be one ratio. You have your landing, and this can be another ratio going up. All right. So these commercials up here, please. Is that a half turn? Yeah, that's a half turn. And then you come up here, and there'll probably be another one. And you go to that one, then there'd be another one, all the way up to the top of the building. Don't think you're going to be a stair expert after this course. Let's see. It is more compact, but the geometry of your house or structure may not allow you to do that. Here's some examples of some half-turn stairs. Okay, 2 flights connected by the landing may be equal or unequal depending on the desired proportion of the stairway opening. So here's one there. This is a compact one. This is spread out. And here we have 2 unequal runs of stairs. Okay. Winding stairs. A winding stair is a stairway constructed with winders as a circular or spiral stair. Quarter turn and half turn stairs may also use winders rather than a landing. Okay, so all this means is your landing plate are at an angle. Instead of this coming up to a solid platform or landing. All right. Let's see. Winders can be hazardous since they offer little foothold at their interior corners. Building codes generally restrict the use of winders to private stairs within individual dwelling units. Okay, that means these are stairs. These are stairs. Okay, it's not a landing. It's not a flat landing. These are actual stairs. That's tread. That's a tread riser. That's a tread riser. And as you can see, if you're going to cut this corner, your tread is very narrow here. Okay, very narrow. All right, got to check your building code. If you can put a regular landing in, that's probably a good idea. That'd be the safest thing. Circular stair is just that, as implied. It's a circular plan that winds up through the center of the building. Okay, the inside radius should be at least twice the actual width of the stair. This inside radius, okay, should be twice the width of your stair, width of your stair. 10-inch minimum at the narrow end of the treads. All right. Now we get into spiral stairs. Spiral stairs. A spiral stair consists of wedge-shaped treads winding around and supported by a central post. Spiral stairs occupy a minimum amount of floor space, but building codes permit their use in individual dwelling units. I got a friend of mine that's got a spiral stair coming out of his office to an upstairs office, but that's not his main egress and access. He's got a regular set of stairs at one end of the house. You do not want to use these as your fire escape stair mechanism. Okay. Now, spiral stairs. There are 2 types. There's a right-hand spiral stair and a left-hand spiral stair. And do I even have that up? No, I don't. Boy, I screwed this up something fierce, didn't I? Here, let's go over here. Spiral stairs. All right, let's open that with edge. And let's open that with edge. Okay. All right, spiral stairs. This is a company that makes spiral stairs. If you're going to put a spiral stair in, I would suggest you find the manufacturer of the spiral stair, get with them and call them and let them do the calculations or how big your spiral stair needs to be. Now, spiral stairs can either be left-handed or they can be right-handed. Okay, left-handed or right-handed. Most of the spiral stairs in the castles in Scotland and over in Europe are left-handed spiral stairs. All right. So if you are on the ground floor and you step on that first tread and the handrail's on your left, it's a left-hand spiral stair. And it's going to screw upwards clockwise. If you step on that first tread from the bottom and the handrail's on the right, it's a right-hand turn, and it's going to screw up counterclockwise. Now, this comes from medieval Europe, okay? And this company says be aware that coding can change significantly by location. Best thing for you to do is, if you're going to put a spiral stair in, is get with these people, okay? And they know all the ins and outs and trips and traps that go on with this. Now, where's the left and right hand thing come from? Well, that's an interesting word. Chirality, right or left-handedness of spirals. This is on D2L also, and it talks about, and go back to the castles, okay? Why did they have mostly left-handed stairs? Well, that's because the lord and lady lived up on the upper floors, and it's from the Middle Ages. And so when somebody came in at night to attack them, since most of the people are right-handed, that means that the attackers, this would be the attacker, this is the defender. I know y'all are just excited as all get out. Okay, this is the defender, and this is the attacker. Okay, attacker. They got to come up these stairs, all right, and the center column post, and since they're right-handed, then their sword is in their right hand. Whereas, and they have limited swing of their sword because they're shoved up against the center column. Then they got their shield. So the defender's coming down to protect the lord and lady from the attackers coming up. They have a full swing of the arc. They have a full swing of that spiral stair. And there's a big center stone column that goes all the way up. And so as they're coming down, they get to swing their sword all the way across that piece of the circle. The guys coming up, their sword swings are blocked by that column. They don't have a full sword swing. So the defender's shields are against the center column, and these guys get kind of smushed up against there. And so that's where it came from. I know y'all are just excited to know that. Okay. All right. Well, anyhow, that's an interesting little article. All right. But that's the history of why most of them are left-handed. Yes, we're going to leave this. All right. So these are up on D2L. So you're going to know whether it's going to be left or right-handed. And you don't really have to worry about swords and defenders these days. So if you need a right-handed stair, because it's going to work with the landing upstairs, then do that. But get with the people. This is mylanestairs.com, and there are a lot of people that make it and prefabricate, and they'll come out, and there are all kinds of treatments. You can see here that the treads are not just steel or iron, they're wood. And but again, you can check your code, and but this is for your enjoyment. It's up on D2L. So that's enough about spiral stairs. Just remember there are left-handed and right-handed spiral stairs. If the handrail's on the left going up, then it's a left-handed. If the handrail's on the right going up, then it's a right-handed. All right. And he gives some rules of thumb for maximum riser heights and minimum headroom clearance. I mean, because yes, 6'6" guy going around these spirals, you're not going to whack your head on the upper tread. Get with the company. They will guide you through all of this. It's just like curtain walls, elevators, or whatever. These people are professionals. That's what they do. You don't want to be spending your design time reinventing the wheel. Wood stairs. Where are we at? Time-wise on this one. We're at 15 minutes. All right, wood stairs. In my humble opinion, if I have a humble opinion, if you're not running 3 stringers on your wooden stairs, you need to be fired. A lot of people try to get away with 2 because they don't want to have to cut a 3rd one. The problem with 2 is you create a drumming effect of the stairs going up. It creates a drum. All right. These are called stringers, are the sloping finish members running alongside a staircase against which risers and treads terminate. All right. Carriages are rough stringers. Most of the carpenters refer to these all as stringers. This would be your rough stringer, and then this would be your finished stringer. Your finished treatment of your rough stringer. And so they're all referred to as stringers. Run 3 of them, and then glue. Make your specification where you use like liquid nails to lay your wooden treads down. You'll buy your wooden treads from a manufacturer who has they'll put a bullnose on them, and these are your finished risers and vertical boards that close off the stair space. This is what's called a closed riser system. We'll see examples of an open riser later. But use 3 stringers and glue them, and the best thing to do is screw them. Nails have a tendency over the life cycle of something with foot traffic to work their way loose, and you really don't want that. That's really bad. All right. Carriages, they're a hanger board for these stringers. You're going to want carrier boards up there. You'll want a carrier header or board here, and you don't give this to the junior carpenter to cut, to lay these out. These all have to be uniform and evenly done. It's done with frame and square. And if you're interested in how to actually cut these things, get on YouTube. Larry Hahn's got a good one. The reference back to that other article with the Rhode Island. He's got a side link where he's laying stringers out. All right. Okay, let's see here. If the underside of the stair is open, you're not going to close it off and use it for storage. A lot of people do that. They'll just try to close this whole thing off and then use it for storage, or make one of the kids that's acting bad live underneath the stairs. I'm just joking. Anyway, but don't forget, these areas can be storage. All right. So if you close them off, you can use them as storage. What's he doing here? Carriage in the spacer, soffit. If this is going to be open and you close it, then you've just created a soffit, just like you would on an overhang of a roof, on an eave. He's showing fire blocking. Your code, your building code, will determine how much fire blocking you need in these stair runs. Just like the building code will tell you how much fire blocking is needed in between a wood stud wall. All right. What's he doing here to us? Okay, here's a handrail that's, we've already talked about the handrail requirements. These handrail requirements are no different than the ones in a commercial building. It's just normal human factors. You do need to run a vertical stringer so you can have something attached to this thing. This is wall framing up your stairs. Some people will run an exposed handrail system up here. If you do, you make sure it's structural and the spacing on the guardrail rungs are within code. And generally the code talks about a certain diameter sphere being passed through. For children, sometimes you need something less than that. And check your code, your building code, because your mileage is going to vary, I promise you. All right. More wood stairs. Here's an open riser. I knew we'd get to an open riser. I'm not a big fan of open risers. That means there is no riser board in here, that the treads span between the stringers, and sometimes you've seen some really cool architectural stairs that cantilever off the wall. This would be like a structural steel member, and then there's welded steel plates underneath here, or some kind of weldment, and then they screw the tread from underneath. This leaves an open riser. I'm not a big fan of these. Some codes may not even allow you, and they don't comply with ADA. And why is that? Because you can slip through that thing. If your foot slips, it'll come off the tread, and you get trapped in here. Your leg will get trapped. All right. Children trying to climb these things have a tendency to fall through if they're small, and they're not being monitored by their owners or parents or whatever. So I would stay away from an open riser. You do what you want to do. It's America. You have the right to do that. I would stay away from them. You may not even be allowed to put that in based on the code. Here's a wood handrail or baluster, and it's dovetailed in, and then the end caps are put on, or the tread return. I'm not a big fan of these because over the life cycle, these things break off, then you got to tear your tread apart and then haul that piece of wood out, and then try to go find another one of these that's dovetailed. I've got wood railing and banisters in my house, and some of them are broken when the kids were younger. And if it was up to me, it'd be a structural steel member that would be lag bolted down through here. So again, let your conscience be your guide. For residential, you can have a happy medium by having this a welded structural steel a guardrail system, and then you can put a wooden top rail on there if you want that wooden feel coming down. Some more detailing. Concrete stairs. Most of the concrete stairs these days are poured in a prefabricated metal pan. If you go out to the Cypress Center and go on the two ends of the building, the two long ends, before you get to the exit doors, go back underneath the stairwells that go up to the second, they're open, and you'll see the structural steel pan that those stairs were cast in. And they can be a part of your structural integrity of your building, depending on how you address the joints. But then again, you got to worry about expansion and contraction. And here's a guardrail that's extended out. Most of them just terminate down. These are embedded in the slab. There needs to be a set of guardrails in here, but this is a cut section. Let's see. You can do a side mount, or you can do a cast in place banister. And these could be cast in place here with cast in place sleeves. Then they set the guardrail in the sleeves, and they come in with non-shrink grout and then fill that up. Some of these are cast in place without a steel pan. The best thing to do is get a steel pan. That way you can adjust and shim the steel pan and get all that erected into the framework or the structural walls, and then come in and then cast your concrete. That way you don't have the expense of having to do expensive concrete forming that you're going to wreck out later on. But your conscience, let your conscience be your guide on that, and your budget, and the needs of your client, and the building code. Here's a cast metal nosing that's cast in with the concrete. This is a metal and rubber or vinyl tread with groove surface that's overlaid, and this is a stone tread with abrasive strips that's adhesed down on the concrete. Commercial stairs do require slip-resistant noses and treads. All right, steel stairs. All right. Steel stairs are a combination of concrete and steel. They're generally a steel pan, like I said before, and then they come in and they pour the treads on these. These are probably the most economical way of doing a durable set of stairs, as opposed to the expense of having to come in here and engineer and shore up traditional concrete forming for stairs. And then when this is all hardened, then you got to come in here and wreck all that out. But don't be surprised if you have to detail something like this up. This does take a lot of special forming. This is not just a slab on grade or floor slab. It's a floor slab basically that is out on angle. Forming is the most expensive part. The forming and the rebar laying is the most expensive part of your concrete. Here we go to steel stairs, okay. And there's a combination of steel pan and cast in place concrete, which you use the steel pan as the formwork. This is what I call a real steel stair. So you've got your stringers that are steel, structural steel, and then you've got flat plate treads that have some sort of textured surfaces on them of all manner. Sometimes it can be bar grading, like in an industrial plant. A lot of wastewater treatment plants I did. That's how we did the steel stairs. Was we used structural bar grading between the stringers. It's very slip resistant, very durable, and it worked really well. Spiral stairs, here we are again. We've already talked about these. I don't think we need to belabor this. Just remember there's a left hand and a right hand. Okay. The way this arrow is going from the bottom to the top, this would be a left hand because there's a handrail. If it was going the other way, the handrail would be, your right hand would be over here and you'd be going this way. Okay. And there, let's see, various connections. Rectangular landing, there's a L-shaped landing, square bottom platform, quarter. Get with the spiral steel manufacturer. Some of them actually come with just a pipe, believe it or not, and stair treads that are cast, and you just stack them up like Lego blocks with their trained construction crews. Again, your mileage is going to vary on these. Here's some representative sizes and dimensions of spiral stairs. Your mileage is going to vary. Get with the manufacturer. Tell them how far you need to run and what you want to do and how much space you got, and they can help you out. Ladders. This is like a ship ladder, okay? Ladders can be vertical or they can be at a steep angle, almost like a step ladder, okay? But they're all ladders. They have their own requirements with the code. and detailing. You need a proper riser height, adequate toe space, adequate support for the strings and rails, and you need slip-resistant treads. And most of these are open tread design, but this is for industrial stuff, not normal pedestrian traffic in a building. This is a traditional ship's ladder. All right. This is going to be a vertical ladder, like going up the side of the building up on the roof. Sometimes they'll have fall protection rails up here so you can hook your harness on, depending on how high they go and depending on what the building code says. You climb back up here. This one shows a platform to clear the top of the parapet so you're not tearing up the parapet with your feet. So you come up here and your next step would be on the platform, and then you'd come back over, and then there's a rung right there to step down. All right. Rungs may be 3/4 inch round bars or 1 inch pipes. The stringers may be channel, angles, or flat bars. There's all kinds of configurations of these things. Now we get into elevators. Man, what a rabbit hole that is. Where are we at on time? We're at 31 minutes. All right. Let's go back over here. Did I have my D2L? No, I closed out D2L. All right. Let me open up D2L real quick, because I put some of them. Well, knocked them out of the folder. I'll just get it out of the folder. Okay. Let's get out of stairs and go to elevators. Open with Microsoft Edge, that way it'll pop up. All right, there's a PDF in D2L in this week's tab that is Elevators General. All these links are good. It talks about the different drive systems, the types of elevators, the concept and capacity, elevator systems and doors, list of elevator fixtures, and it talks about elevator drive systems. I think the dog is protecting me from some nefarious activity that's going on outside. Whatever. I've got a pistol right here by my desk. I'm not worried about it. Anyway, drive systems or traction, motor roomless, where the motor drive system is not like up on a doghouse, winding drum, and hydraulic or hydraulic. So this covers everything you ever wanted to know about elevators. Let's look at something else that I put on D2L. This is a link out of that. Let's open it with Microsoft Edge. Hydraulic elevators. Right? There's more than one type. There's a holed, holeless, roped, machine roomless hydraulic elevator, and the benefits of hydraulic elevators, and the determinants of hydraulic elevators, and notable hydraulic elevator models, and all right. Now, so peruse through all this. This will let you know the real world take on these elevators. Now, Otis, the Big Mac Daddy of elevator systems, Otis Gen 2. I put this up there. I got this from Otis. Here we go. This is copyrighted in 2017. I am sure that they have gone into higher technology since then. This is a Gen 2 machine room, which means the machine room and the drawworks is up on top of the building at the top of the path of the elevator. This is a machine room less, MRL. Okay, So all the machining stuff is inside with the elevator carriage. All right. So that's why they call it a machine roomless. All right. Oh yeah, it does. Okay. Here's some rules of thumb you can use from Otis. If you're going to do one of these and you really want to get deep into the weeds, contact Otis Elevator Company and get the current technical specifications. This is everything you ever wanted to know. All right. The hoistway plan, what dimensions you need. You are not going to design these elevators. You are going to contract this out to Otis or whoever is the elevator people that win their contract, and they will bring their construction crew in. They're people that work for them, and you'll sub this work out. But you'll have to supply, your structural engineer will have to supply the hoistway at the proper dimensions for the hoistway. And if you have a motor room on top, they'll have to do that, et cetera, and your structural engineer is going to want to use this as a shear column, much like the pagoda pole, depending on the geometry of the building. All right. And here's one that's machine roomless, an MRL elevator system with the duty loading and the dimensions required to handle all this. And they'll bring all this stuff in parts and they'll assemble it and install it inside that column. All right. Now the other one that I put on there, let's open that up. And Microsoft Edge. This is also in D12. Aren't y'all ready to quit? I know I am. Sunday afternoon. Let's see. You can read through this. It's like, I mean, it's been around for centuries. Okay. This describes what a holeless hydraulic elevator is. The Otis escalator. How much space it's going to take generally for an escalator. Escalators eat up a lot of room. They're a maintenance headache, and when they don't work, you got to close them off because you cannot use a downed escalator system as a stair because the tread and the riser ratio changes as you go up, and it's very dangerous. So anybody who does not close off an escalator that's down or that's malfunctioning is just asking to get sued. Otis has offices all over the United States and Texas and Canada and Guam and Puerto Rico, and here's the Houston office, and one of our field service technicians got that level 1 certificate. He's working for Otis Elevator as a elevator repair technician. He's making overseer once he gets apprenticeship, which is pretty cool, I thought. All right, let's get rid of all of this. And all this is on D2L. How deep in the weeds on elevators are we going to get? Not too deep. Oh, room is going to take to put in X elevators. ADA has its own elevator requirements too, and Otis can help you with that. All right, so elevators. A penthouse is generally referred to penthouse, doghouse, machine room, whatever. It's at the highest part of your structure. It's above. It provides the drawworks for the elevator system and all that Hollywood stuff you've seen about people being heroes and climbing up and down through elevator shafts and that kind of thing is it's all Hollywood. I know some elevator repair people that have gotten badly injured working on elevators. All right, the penthouse sits on top, and it's where the machining is, machine room. Control panels are up here. your control panels, your hoisting machinery, um, heavy steel beams support all this on the reinforced concrete or structural steelwork. The driving sheave is the hoisting pulley. The pulley on a crane is called a sheave. The idle sheave tightens and guides the hoisting cables of the elevator system as it moves up and down. And you don't want any slack. You don't want any bump as you're going up. Landing is the portion of the floor where the elevator stops. The elevator car, a safety device for slowing down and stopping an elevator. You can imagine if this building is 50 stories, you don't want some slow elevator. So the elevator will have to increase in speed perhaps if you're going. Some super tall high-rise buildings have two sets of elevators. One for like floors 1 through 20 and then maybe floors 20 through 50. Let's see. The elevators all have brakes on them. Everybody's worried about free fall. Here we go. Elevator car safety is a mechanical device for slowing down and stopping an elevator car in the event of excessive speed or free fall. Free fall means the cable breaks and this thing is dropping like a rock. All right. It has side brakes that click into the rails on the side, and then there's usually some kind of spring down here that can you land on. Let's see, actuated by governor and clamping. Hoistway. The hoistway in an elevator landing is normally closed except when an elevator car is stopped at the landing. Well, no duh. Okay? You don't want the door open if the elevator's not there, right? So all these have safety mechanisms, limit switches, and they're tied into the programmable logic controllers now. And it's quite extensive how they control these things electronically. Some of these elevators, they have variable frequency drives, which means the motor runs at a different RPM depending on where the elevator's at. In between floors, it might go a little faster and then slow down. The buffer is the piston that absorbs the impact of a descending elevator or counterweight at the extreme lower limit. So when the car gets up here, the counterweight comes down here, then there's usually a buffer, okay? And then this is the oh no buffer spring down here. The last thing you want to do is fall in an elevator. Elevator pitch, the portion of the shaft that extends from the level of the lowest landing to the floor of the hoistway. Now, if you have an underground garage, water is not a problem, right? But if this is a slab on grade, then groundwater might be a problem. Or if this is a basement. And a lot of times what they'll do is they'll put this down in a basement, and then they'll have an access door for the maintenance people down here. If not, then they got to open this door, they got to shut the elevator off, bypass this with a key, open it, then crawl down in this space. Okay? So it depends. Some of these can be quite extensive. All right? Here's some more definition. Riser travel. A limit switch automatically cuts current in an electric motor when an elevator car has passed a given point. Counterweights are heavy weights that balance the weight of the car. I already talked about the guide rails. And there's your traveling cables. Electrical. The shaft that the car travels in is officially called the hoistway, and hoisting cable, and the top floor. Okay, I think we beat this up enough. That's electric elevators. Why they call them electric elevators? Because they're driven by electric motors. Aha, yeah. And they're capable of speeds up to 350 feet per minute. All right. And gearless traction elevators are available with speeds up to 1,200 feet per minute. That's gearless traction elevators. It means the traction motors are on the car itself controlled, and they run up and down tracks in here. All right. There's all kinds of different elevator configurations. Hydraulic elevators. That's what we have at the Cypress Center. That's what you have at um, Sci-Fair. And UP, I think that's only three. No, UP's got more floors than that. I don't. That's not going to be hydraulic at UP. Those are probably conventional hoistways, if I'm not mistaken. But nonetheless, hydraulic elevators are just that. They're hydraulic pneumatic. They're driven by a hydraulic piston that pushes the car up and down, and that's the hydraulic piston. The piston ram down in the ground, usually in like a caisson, suitable soil, and they have a hydraulic room off to the side. That's what we have at the Cypress Center. The hydraulic room is the door right beside the guard desk at the Cypress Center. And of course, our elevator only goes 2 floors. All right. That pretty much covers that. You can read more than you ever wanted to know in those things I put on D2L. Elevator layout. This is an architect you'll probably have to worry about. How far apart are your elevators? Okay. 1 3/4 times the car depth. If it's just a solid wall, then 1.5. 2 times the car depth, or 12-foot minimum, or a 10-foot minimum. 8 cars per row maximum. And the big deal, consult the building code and the elevator manufacturer for recommended type, size, layout controls, and installation requirements. That is the safest thing to do. That should be the first thing that you do, and get them on board. Okay. And here's 2 or more hoistways are required for 4 or more elevators. Your code will tell you this, so will the manufacturer. So you may have to have 2 or more of these. 2 or more of these penthouses or hoistways, or a huge penthouse over here with several hoistways up there controlling each elevator bank. Okay. Where's my ADA stuff? There it is. ADA accessibility guidelines. Talks about visible, braille, call buttons, and elevator doors to be provided with an automatic reopening device if the door becomes obstructed. All of these do that now, assuming they're working. A doctor at the medical center years ago got decapitated because for some reason he decided to stick his head out the door as it was closing, and the automatic closure thing didn't work. Automatic opener didn't work. And it was a bad end for him. And I imagine it was a bad deal for the people in the car with him. But nonetheless, there was some malfunction with the automatic reopening device. Most of them are pressure, and they also use a light, like on an overhead garage door, where you break the beam at the bottom and then the pressure panel. Some of them have a limit switch. So just the slightest pressure on the door as it's closing retracts the door open again. Okay, ADA requirements on the inside. It's 68 inches minimum width for cars with side opening doors, and 80 inches minimum for cars with center opening doors. 51 inches minimum car depth, and 36-inch minimum clear door opening. Here we're back at that 36-inch, not 32 in doorways, right? Okay. All right. Is 36 inches. Should be your rule of thumb for everything. It is mine. Elevator cars should be sized to allow wheelchair users to enter the car, maneuver within reach of controls. They got to be able to turn around and then get to the controls. Okay. So look at this picture here. So if this paraplegic is stuck up against here, then he's got to bend over and reach these controls, right? So he's got to be able to maneuver sideways so he can get to these, right? You would think with the way Alexa works, you could just have voice activated. Floor 2, please. Maybe in the future they'll do that. But then you got people talking in the elevator and it'll confuse the voice commands. So maybe that's not a good idea. Open the pod bay doors, Hal. I can't do that, Dave. Anyway, I digress. I can't believe I said that. All right, okay. Here's that 48 inches again for height. They should be at least 36 inches above the floor, 35 inches, and no more than 48. We've seen that figure before. Where we see that? Door handles? Yeah, we did. And then raised umbrella designations and audible visible car indicators. We've already talked about the braille. This is like floor 2, floor 1, floor 3. 80 of building code will have their own escalators. Boy, these are a pain. Man, do these eat up a lot of space. They're expensive, and that's probably a good place to stop. This is 52 minutes. What is this, 52 minutes? 51. All right, let's go ahead and stop this. All right. So this will be, we just finished video 2. This is going to be video 3. So this will be 9, 3, escalators. I hate escalators. They're a pain. But we'll talk about escalators on the next video.